Welcome back to the channel. Today we are diagnosing a classic digital domino effect on a FANUC Series 0i-MF controller. We're breaking down a common cascade failure, the SP9015 Spindle Switching Fault, and establishing a progressive troubleshooting routine to isolate the hardware and clear the e-stop lockout. When this fault hits, the screen looks chaotic. You're greeted by a hard emergency stop state with 5 distinct flashing alarms. We have the core drive fault SP9015, machine builder PLC faults EX1036 and EX1033, and the standard consequential noise from the safety string breaking. The core takeaway here is simple. 5 alarms do not mean 5 broken components. This is a single hardware failure causing a digital domino effect. To fix it, we have to ignore the digital panic and isolate the hardware. Let's look at how this sequence unfolds. Step 1 starts when the spindle drive commands a winding shift between low-speed star and high-speed delta windings. In Step 2, the hardware miss occurs. The star contactor either fails to physically close or fails to deliver the microswitch feedback. By Step 3, the PLC detects the missing feedback and trips a logic fault. Finally, in Step 4, the broken safety string drops the entire machine tool into an emergency stop. To troubleshoot effectively, we use an alarm decoder matrix to filter out the noise. Tier 1 is our root cause area. Look at SP9015 and EX1033. These point directly to a timed-out transition and a missing auxiliary feedback contact from the star contactor. Tier 2 is the system logic halt, EX1036. Tier 3 is the resulting noise, EX1004 and EX1003, which you can completely ignore until the root hardware cause is resolved. Before we touch anything, safety first. Because the machine is locked in an e-stop, we must physically access the electrical cabinet. The golden rule applies. Turn off the main breaker, execute full lockout/tagout protocols, and verify zero energy before inspecting the spindle switching hardware. Phase 1 focuses on the mechanical layout. Your spindle winding relies on a pair of physically interlocked contactors. Here is the critical constraint. If the delta contactor is welded shut or binding, the physical interlock bar will prevent the star contactor from engaging. Additionally, keep an eye on the PLC's blind spot. The PLC doesn't actually see the contactor move. It relies completely on these auxiliary microswitches. If they are coated in oil, coolant, or dust, the PLC assumes a failure and throws an EX1033, even if the contactor mechanically shifted. With power isolated, locate the contactor pair near the spindle amplifier. Step 1 is to manually press the armature of the star contactor to check for smooth movement. If it's rigid, inspect the delta contactor to see if welded contacts are holding the interlock bound. Step 2 is to inspect those auxiliary contacts. Clean any residue off the microswitches and pull out your multimeter to verify continuity across the contacts when actuated. If the contactor moves perfectly fine by hand but won't pull in electrically during a cycle, Phase 2 is your control circuit diagnostic. First, meter the star contactor coil resistance to confirm it hasn't burned open. Second, trace the wiring back to the PLC output card and check the surge protection diode or veristor across the coil. These are notorious for shorting out. Finally, check for blown fuses or tripped breakers on the auxiliary 2-4 VDC lines servicing the output relays. If the physical mechanism and the 24 volts control circuit check out, clear the panel doors, safely power the machine back up, and look directly at the 7-segment display on the FANUC Spindle Amplifier unit. If the hardware display reads 15 feet, it perfectly matches our SP9015 CNC screen alarm, validating that the problem is external to the drive, meaning the cabinet contactors, or switching logic wiring harness. If it shows a different internal subcode, the fault is likely inside the amplifier's internal switching circuitry itself. To summarize your approach, use this quick isolation matrix. If the contactor is physically rigid, resolve the mechanical interlock or replace the welded contactor. If it moves manually but fails to pull in, use your multimeter on the 24 volts lines, coils, and diodes. If the drive display shows a NON15 subcode, cross-reference the FANUC manual for internal drive maintenance or parameter rebuilds. If you need to momentarily clear the e-stop condition to move an axis or check active screens, you have 2 diagnostic options. Method A is an MDI override, attempting to force a reset sequence by manually executing an M41 or M42 command, depending on your machine builder's setup. Method B is PMC signal tracing. Navigate to your PMC diagnostic screens to monitor the switching keep relays, your K parameters, or the status of the G and F feedback signals to see exactly which logic bit is hanging up the validation sequence. Let's tie everything together into a definitive diagnostic algorithm. Start at the top with your SP9015 and EX1033 alarms, power down and lock it out. Check if the contactors move freely by hand. If no, fix the welded or jammed hardware. If yes, check the auxiliary microswitches for cleanliness and continuity. If they fail, clean or replace them. Next, check if the 24 volts control circuit is intact. If fuses or diodes are blown, replace them. If the circuit is good, power up the machine and check the FANUC amplifier's 7-segment display. If it shows code 15, look for a wiring harness break between the PLC and the contactor. If it does not show 15, you are dealing with an internal drive failure and should consult FANUC. Follow this sequence, and you'll reliably clear the machine for reset. Want to support the channel? If this video saved you time and money on the shop floor, you can now support my work directly by clicking the Super Thanks button right below the video. Your support goes a long way in keeping these highly specialized technical guides coming. Thanks for watching. Drop any questions in the comments. Keep learning, keep sharing, and keep curious. See you in the next one.